Hi, good evening to all of you. Welcome to this session of education webinar series organized by ACM India Council. So ACM is world's largest educational and scientific computing society. Its mission is to advance computing as a science and profession. And you can see ACM India at a glance on this slide, but let me give you some examples of what being a member of ACM means. You will be part of world's largest computing society. Out of the 1 lakh members worldwide, about 14,000 are in India, and half of them are students. And there are at present 250 student chapters and 25 professional chapters and 40 ACMW chapters. And you can easily become an ACM professional member or student member through these forms which are available to you at the ACM India website. And there are quite a lot of research initiatives. There is this Arts Symposium, which is being conducted during ACM India annual event. And there are this best doctoral dissertation, which is given during the ACM India annual event. And there are partial travel grant, which is given to you to attend the various conferences. And there are new things like the research, that is this ROCKS event, which tells you about research at computer science. And then this PhD clinic event where different people from industry as well as the educational institutions, they will be interacting with you one-on-one. And Anveshan Setu is a initiative which gives an immersive experience at a particular institute for an extended period of time. And then there are SIG conferences, which are from SIGSoft. You have this ISEC conference in the area of software engineering, and then COTS-COMAT conference in the area of the data science. Then for the first time this year, this Pingala interactions in computing that has been started, which will be for an extended period of time, like 4 days in an exclusive setting where you get to interact with people for a very extended period of time, a unique kind of a setting, like a Heidelberg laureate, that forum inspired by that. This Pingala interactions in computing has started this year. And there are several education initiatives, summer schools, winter schools, which is for an extended period of 2 weeks. One of these schools will be exclusively for women. And then there is this symposium on computing education, Compute, that is annually organized. There is this teaching partnership program where external experts will be co-teaching with a local teacher. And that has been there for now for 3 years. It has been organized at different institutes. And then there is the CS Pathshala initiative, which inculcates computational thinking at schools. And as part of this, there is CTIS conference that is annually organized. And there is this eminent speaker program where different eminent speakers can be invited to your conferences or workshops, and their travel will be covered by ACM India. And like this webinar, this education webinars are organized every alternate month. And every alternate month, the industry webinars are organized. And then boot camps, which will be very helpful for industry professionals, that is also being organized. And mini graphs, which gives comprehensive coverage of an emerging technological area, and that is periodically published. Then you have this kind of the resources, digital library, and other things that are plural site Percipio, which are part of ACM Learning Center. You can access all of them. Then ACM India recognizes outstanding contributions in different areas and provides awards during the ACM India annual event. Underlying all of this, there is this diversity, equity, and inclusion, which runs across. And ACMW India, it kind of empowers women in computing. As part of that, Lady Ada contest that's organized, and ACMW hackathons, which are exclusive for women, that are organized. And all this, with this, now I will come to the today's webinar, which is on simple code writing problems that GenAI cannot solve, at least as of now. That is going to be given by Dr. Viraj Kumar. And it's my pleasure and privilege to introduce Viraj Kumar now. He is a visiting professor at Kotak-IISc AI/ML Center, and he is also a member of the ACM India Council. Currently, he heads the ACM India's Committee on Educational Initiatives. His primary research area is computer science education, and he has co-authored Indian Institute of Sciences policy on AI usage for teaching, learning, and research. He is a member to the Ministry of Education Committee to study the impact of AI on engineering education. He has served as a consultant to the Kasturi Rangan Committee to draft the National Education Policy, NEP 2020. He holds a PhD in computer science from the University of Illinois at Urbana-Champaign. And now I will hand it over to Viraj Kumar to talk about this today's topic and enlighten all of us on how in this era of Gen AI, we can rethink about an effective way of assessing the students. Over to you, Viraj.
Thank you so much. Thank you, Professor Chitra, for this warm introduction and for the opportunity to present to all of you. I will just share my screen. And can you see my slides now?
Yes. Yeah.
Okay. Okay. So thank you, everyone, for attending this talk. As is there clear from the title, these are some ideas to thwart Gen AI, at least at present. And I will talk a little bit towards the end about where I see some of the threats to ideas like this coming. But first, some clarity on the terms. So when I'm talking about simple code writing problems, I'm really focused on sort of the introductory CS1 level problems. I do think these ideas could be extended further, but I have only explored them in this context. When I talk about GenAI tools that cannot solve such problems, I'm focused on tools that are presently accessible to our students, tools like ChatGPT, tools like GitHub Copilot. Once again, I do see possibilities for advancements in these areas where potentially this approach may not work quite so well. So with those caveats out of the way, let me just talk a little bit about why I think such problems are interesting. I hope I'm more or less preaching to the converted here, but again, just for completeness. So, the current ACM IEEE curriculum that's out there does reiterate the previous curriculum's stress on code writing as an important learning outcome. They talk about not just code writing, but they use this broader term developing, code development, which consists of these four components. And you will see that in the learning outcomes, lots of them focus on getting students to develop programs. And therefore, writing, of course, is an important component to that. So given that code writing remains an important skill, we have to acknowledge that these Gen AI tools are actually very good at writing code, at least for the simple problems that we see in introductory courses, right? At SIGSI last year, we presented this paper where we did a study. We used a public repository of about 160 Python programming problems. And if we found that if you simply copy paste those problems, then at least when we did the study, 50% of those solutions produced by the generative AI tools at that time were perfect, right? And even when they were not perfect, here's an example of a problem from this data set where the GenAI produced an incorrect solution. If you take a moment to read this problem, you will realize that the GenAI solution is more or less right. I mean, if you were the instructor and a student had produced this, you might be tempted to give them a reasonable amount of partial credit. Of course, the formula for calculating the average is complete nonsense, right? Please remember, we did this study in the summer of 2022. If you were to try the same example today, you get a perfectly correct example, even handling a corner case where you might have divided by 0. But back to the study when we did it, we did ask the question, okay, what about the problems that it cannot solve? And one thing we realized was that if the student engaged in algorithmic thinking, meaning tried to explain what to do step by step, then the AI was able to produce correct code. So because of correct code like this, this number actually jumped up to 80%, right? So this does demonstrate that these kinds of tools can solve such problems. Now, this particular data set has been out there for a very long time. And so a reasonable concern is that the reason we're seeing very high scores on such problems is maybe because these generative AI tools have simply ingested all this as part of their training data, and they're just mugging up and reproducing. And so maybe this is not such a problem as much as I'm making out to be. But we can counter that particular argument, right? So there's a very nice project called Live Code Bench, which maintains a repository of recent coding contest problems. So, and you can control the slider to make sure that you're looking at problems that are well past the training dates for some of these large language models. And many of these coding contests categorize their problems as easy, medium, hard. So assuming that the easy problems roughly correspond to introductory programming courses, you will see that the top models, this list is very long, the top models perform very, very well, right? So I think it's fair to say that these tools are very good at solving such problems. And these tools are easy for students to access. So if we as instructors want to motivate our students to work on their code writing skills, especially in unproctored environments, which is where we really want to give them time to develop this skill, this seems to be concerning, right? How are we going to motivate our students to avoid just simply appealing to these tools? In fact, a good student really should be asking us, look, if these tools are available and they can solve such problems, why are you asking me to develop this skill? In which world, for which world are you preparing me? And I think that's a good question. And I think students deserve a good answer to such a question. So you might say, look, this is not a new problem, right? I mean, isn't this the same as the copy from the internet problem, right? Well, if you ask a standard question, like here, there's a standard question around what are Niven numbers. So these are numbers where the number is divisible by the sum of its digits, like 156 is a Niven number. So if you asked a standard question, pre-generative AI about, write a function to calculate, to check if a number is a Niven number, of course, somebody could just go to Google and get the code, right? So at least in the pre-generative AI era, we had a way to counter this, right? I mean, we don't have to call these things Niven numbers. We could call them something else, like how about alpaca numbers? And then if they Google for it, they're not going to find it, right? Of course, we have to give the students the definition of what we mean by an alpaca number. The problem is if we give that definition, even if we do call it an alpaca number, not a Niven number, the AI is smart enough to take that detail and produce the right code, right? So this code that you see is roughly the same as the code that we just saw over here, right? It's packaged in the right form factor. But these generative AI tools are not going to be fooled by simple manipulation of keywords and terms like that, right? So this doesn't seem to be a viable way of preventing students from using these tools. The other thing you might say is, well, we're going to check for plagiarism. I mean, if everybody is using GenAI, then we're going to count that as plagiarism, and we will have AI, tools to detect such plagiarism. You may or may not know about this classifier from OpenAI. The reason you may not know about it is it lived for a very, very short amount of time, just about 6 months. And they had many limitations even when it was there. One of them was that it's unreliable on code. So as an educator, I'm very afraid to use tools like this, because if my student really has done the work herself or himself, and I use a tool like this, which claims that it was plagiarized or AI generated when in fact it wasn't, then on the basis of the report of this tool, this false positive, I might falsely accuse my student, and I would destroy the trust relationship I have with my student, right? And so I don't think either of these approaches, works. I think this problem really is different in some sense. So here is the proposal that we would like to make, and we are actually acting on this at IISc. I've also been talking about this to other institutions, so I'd love to share it with you, get your thoughts on it, right? So our approach is presented in this paper, which if you're interested, you can look at. We'll also be presenting a fuller version of this at ICER next month. So the idea is to give simple code writing problems, but to actually delete certain details. So we deliberately remove certain details, right? So for example, if the question was count the number of distinct vowels, English vowels in a given string, we might remove the word distinct. And we might also remove a statement like this. So the full problem specification may have been this whole thing. And if we gave this whole thing to generative AI, it is likely to produce the correct code because this is not a very difficult problem. But by removing these details, you run this to the generative AI, and it produces code that does not account for distinct letters. How could it? It didn't know. It made an assumption, though, that you did want to treat repeated vowels separately. It also made an assumption that you want to treat uppercase vowels differently from lowercase vowels in the count, right? So these details matter. And arguably, someone who really wanted this behavior, but did not know enough about programming, like the client who was asking you to develop the software, that person may easily have said a statement similar to the one outside the green highlighting, something like this: count the number of English vowels in S. It was very clear that the programmer should ignore the distinction between uppercase A and lowercase a. And maybe in their mind, it was very clear that by counting, I mean, don't count the same letter, the same vowel twice. I just want to see how many vowels there are in this string. So this could have been the request that your client made, right? And if you give a statement like that, you could mean something different, and your AI may not know that, right? Now, of course, that's not enough. You must also provide the student a mechanism to ask this client some clarifying questions, and finally to confirm whether they have found the right answer, right? So to illustrate what this might look like, here is what our ask interface looks like. You can write in any string over here, and then when you click on this button, the client will tell you what they want, right? So they say, well, on ABC, I want to return 1, right? So you use this to clarify your doubts. You notice that I am putting the onus on my students to ask clarifying questions. And I think this is something important for us as educators to reflect on. Real-world problem specifications can be ambiguous. As educators, traditionally, we have worked very hard and have been very proud of the fact that our problem specifications are complete in some sense. Oftentimes, and certainly I'm speaking here personally, but I hope this is not just restricted to me, I used to be quite upset with myself if a student pointed out an ambiguity in my problem specifications. And I would have to issue corrections, or perhaps even in the worst case, withdraw the question entirely if the problem I deemed was deficient, if the problem specification was deficient in that sense. But now I feel I'm actually doing my students a disservice by doing all that hard work. I think real-world problem specifications are much more likely to be deficient in detail. And I think students should be encouraged, even from the first year, to seek such details, to develop the ability to ask clarifying questions, right? Of course, at some point, they do need to know, well, I think I've asked all the questions I wanted to, and here is my code. So I also need to provide them a way of confirming. And that would look very similar to the normal way in which you would, auto-grade a solution. So I would now request Professor Chitra to share links 1 and 2 with all of you in the chat. If you would like to follow along with me, I will switch over to, this should be link 1 that Professor Chitra has shared, and we can actually try it out, right? So on this input, if we tried, for example, what should happen on the empty string, right? That may be an interesting corner case. The client would respond, well, obviously, in that case, you should respond with 0, right? And if I ask, well, what about this string, India? Notice that I have the letter I repeated, but one time it's capitalized. Expecting the answer as 3, but in this case, the system responds by saying that I should return 2, right? And this might be surprising to the student, right? I would like the student to turn this surprise into a more detailed problem specification on her or his own. And then perhaps they can use generative AI to produce code for that more detailed specification. If, on the other hand, the student just simply took this and put it into the generative AI, they would find that the code is incorrect. So if you move now to link 2, and if you replace this with whatever code we had previously seen that the generative AI had produced, this was without any assumptions, just this very bare bones problem specification, then this would now run some hidden test cases, and although some of them pass, right, many of them fail, right? Because, of course, the AI didn't know. And that's because the student didn't ask, right? So that's the basic idea. I will leave you with the links to mess around. If any of you discover something interesting, please do share that in your Q&A, and perhaps we can discuss, right? So once again, each one of these problems comes with a problem specification that is deliberately missing key details. And we provide our students with 2 mechanisms. One, to ask clarifying questions, and the second, to confirm their answers, right? Both these mechanisms are necessary. There may be no end to clarifying questions in some cases. So let's take a look at how one might design such questions if we really were to take this idea forward. Okay. So there are some questions. Professor Chitra, just let me know if there's something on the chat that needs immediate attention. Otherwise, I will continue with my slides. Okay. So here is how we suggest creating such questions. So start with your detailed problem specification, and then figure out some details to delete. And of course, the key question is, which details should we delete? Now, we don't know of any sort of scientific mechanism for doing this, but we will suggest what we have tried. Right? So these are just suggested categories of details that one could consider. Right? So everything below this this first paragraph is scheduled for the chopping block. Right? Some things that are going to be deleted are definitions. So for example, what exactly do we mean by maximum profit? This is a very standard question, which you may be familiar with, where you're given a list of prices of some stock, and you have to figure out the optimum day to buy and sell the stock in order to earn the maximum profit. Well, what exactly do we mean by maximum profit? There are some details about what does and doesn't constitute maximum profit, which are explained inside this gray box. Those details are deleted, right? What should the code do on certain inputs? For example, what if the list is empty? Or what if the list is such that there is no possibility to make a profit, right? So behavior on specific inputs or behavior on whole classes of inputs could be considered for deletion. Now, there's an interesting subcategory here. And many of these, in fact, all of these suggestions are actually based on us reflecting on the kinds of omissions we made when we were trying to be very clear and precise and complete in our problem specifications. One thing we realized in that self-reflection was many times in the problem specification, we highlight what the code should do in specific cases. So I'd like you to think that we're kind of shining a torchlight on positive values in this case. What we sometimes forget to do is, what should we do then on values that are not positive? Well, those are kind of left in the shade, right? And so those ones potentially we could deliberately delete. Once again, that's behavior on certain inputs, but I'm sort of separating it because in some sense, we deleted this partly because we were shining light on this other set of inputs, right? And so we were sort of taking attention away from these other ones, right? If you're dealing with a language like Python, where the return type is not fixed, you could have many different types of returns, then you might want to say that. So in this case, sometimes it returns none, and sometimes it returns a tuple. So some of the details could be removed around some of those types. And then here's another thing that we often found ourselves forgetting. We often talk about things like the best or the first or some using the definite article in some cases, when in fact there is an opportunity for multiple such occurrences. So the question then becomes, well, what is the tie-break mechanism, right? What if there are more than one pair of best days to buy and sell in order to achieve the maximum profit, right? So parts or all of the tie-break mechanism could be deleted. In this particular problem, the tie-break mechanism was complex, right? There was a first condition, and then even the first condition could fail to resolve the tie, in which case there was a nested condition. And in this case, we got rid of everything else. So we slimmed down the problem specification from this complex detailed specification to just these handful of lines, leaving huge holes in the problem specification. Now, interestingly, the behavior of generative AI, and we kind of saw this in the example earlier, the current AI tools don't look at this problem specification and say, wait, I can't generate code for you because I don't know what to do in this case and that case and this other case. They are so eager to produce code that they will happily write code where all of these things are taken care of, but on the basis of assumptions made by the AI, right? So if a student of ours is capable of carefully looking at that code and spotting those assumptions, and recognizing that those are assumptions that are not mentioned in the problem specification, then that could provide them a way of asking clarifying questions. So we do see our students potentially using generative AI as a way of actually developing good questions to ask, right? It could be an iterative dialogue where you're actually using this eagerness of the generative AI to propose a solution, and then using your own judgment to recognize certain ambiguities that have been filled in based on assumptions made by the AI, right? It remains to be seen whether our students can get good at this, but this is certainly an idea that we are trying to explore, and we would like our students to get good at this, right? Now, I think these problems are actually quite resilient to GenAI. And the best evidence I have that I would like to share with you for this is we actually conducted a 90-minute programming contest where contestants were allowed to use AI. So we conducted this at the ACM India Student Chapter Summit a few months ago. So we had teams from multiple institutions, and these are all active members of their ACM students. We presume they are therefore good at programming and certainly committed individuals. In these 90 minutes, they had 5 problems. We had a total 2-hour slot. Our paper that I referenced earlier on arXiv describes the contest details more fully if you're interested. But the first half an hour of the 2-hour session was spent in explaining the idea because, of course, we knew that our contestants were unfamiliar with this. So we went through one example similar to what we just presented to you, and then they were given 5 of these problems, right? And there were many missing details. One of them, this max profit, we just spoke about, right? And overall, we found that out of the definitions and the behavior on certain inputs and the return values and the tiebreaker mechanism across all those different categories, students were unable to recognize that details were missing, right? And overall, they just found about 20% of the missing details. If you looked at their solutions and recognized that, yes, at least this solution, even though it is not perfectly correct, it does recognize what to do if the list is empty or if the maximum profit can be achieved in multiple ways. They were able to recognize only 20% of those types of missing details, right? So overall, the performance on this code writing contest was quite poor. And this is, as I said, despite the fact that we had students who we believe were motivated, who had 90 minutes. It's possible that we made this contest really hard. By the time they got to problem 5, I think they were completely flaked out and perhaps demotivated by the fact that they weren't getting any of these problems really well. And this is something that we are trying to do. We're hoping that the Lady Ada programming contest this year will include some of these problems. We're working with the team to potentially do that. And we're also hoping to run some contests out of IISc. If any of you would like to run such a contest at your institution, I really would love to hear about it. And if I can, I would be happy to contribute ideas to such a contest. Let me tell you how we're actually planning to incorporate this into our pedagogy. So while I think their use in contests is interesting, I do think we can incorporate them meaningfully into our formal education system as well. So we're planning to make all our code writing exercises of this type. Our students will be solving these in lab. We're planning to do away with week-long homework problems. We think that there's just too much opportunity for students to just share ideas with each other and really not try and do the work themselves, right? But we're going to give students the links in the reverse order that we just gave you, right? So firstly, we're going to give the students only the confirmed links, and we're going to ask them to work in teams. We think this is also very helpful, very realistic, reflective of the real world where students will work in teams. And we have also found, we have experimented with these problems in various contexts, not only the contest that I explained to you, but also in some of our faculty training programs where I have given such problems to groups of faculty to work with. And it's very, very interesting to see people discuss. And many people have told me, this is anecdotal, that by working in teams and sharing ideas, they've been able to surface ambiguities that they may not have been able to surface working individually. So we think this is just sensible to do. Okay. Now our TAs will be given the ask link. So the TAs will basically serve as the clients here. And we're going to incentivize our students to actually approach their clients and ask clarifying questions. One thing we have observed from doing some of the trials that we have done so far is that many people are reticent. They're hesitant to ask clarifying questions. They think in some sense, well, I should have worked this out myself, right? And in fact, I think the ability to ask at least good clarifying questions is important and something that should be encouraged and we should try and develop. So it remains to be seen precisely how we will do this. There is a small refinement here. Right now, the clients, the ask links that I have shared with you, the one that I have shared with you, and I will share another one. They're very good clients. they will instantly answer any question that you might have. And of course, no real world client is like that. We do want to make sure that our students ask quote unquote good clarifying questions. And we do have some ideas about how we can make our clients stay silent or be dismissive of questions where it's clear from even the given details what should be done. Our hope is that by doing so, we're not damaging or hurting our students' ability to understand the task, which is, of course, very important, right? They have to be able to comprehend the task. So if something is clear as per the given limited details, we don't want the student to have this easy way of just asking the client every time. So we have some ideas about how we can, either rate limit or otherwise, give students a sort of more limited opportunity to ask clarifying questions rather than just these very, very generous clients. So I want to summarize and leave a few minutes time to do one more demo with all of you. So I do think that these problems, we've officially called them probable problems, but many people think, like, why don't you just call them ask the client problems, which I think is a good name, right? So they do appear to be GenAI proof, at least for now, right? And here I will share just one example of the kind of work that I think might, in time, defeat such tools, right? As such problems. So I do see this as as an arms race in some sense, right? So in this paper, so it's by the same authors, the one I just shared with you, my undergraduate student Mrigank at IISc and myself. What we did is we essentially relied on the fact that you can prompt these AI models to produce multiple solutions. And our hope was that if the problem specification is missing details, then across multiple invocations of the AI model, we might get different ways of filling in those ambiguities, right? The AI might make different assumptions, right? Fundamentally, these generative AI models are not deterministic. So there is some element of randomization involved. And so we might find different completions for the same ambiguous problem specification. And now that we have multiple concrete implementations that are functionally inequivalent, any input on which these are inequivalent could be an input that is worth getting clarity on, right? So this approach, and certainly there will be more sophisticated approaches, including these agentic approaches that are now being tried out. It's quite possible that these kinds of approaches will actually be able to pause the generative model and say, look, I'm not going to produce code unless you first clarify all these details. And this could be very useful, of course, to developers in the real world. As we've said, real world problem specifications are often missing details. So a tool that helps the developer surface those kinds of questions, which can then be given to the client or to others who are interfacing with the client, that might be very useful. I do think, though, that at least at the present time, such problems are worth exploring. They might help our students develop this ability. If such tools don't materialize in the near future, I think it gives us some clear outcomes to try and target, right? I do fear that our current emphasis on mere code writing is leading to preparing students for job roles that may no longer exist, right? I mean, junior level job roles that are shielded from chatting to the client. Such job roles may either disappear entirely, or those people might need to be more client facing. And I think developing our students' ability to gain these skills might actually prepare them. I must clarify that I have never worked a day in the industry. I know there are people in this webinar who are much more aware and having worked in industry or are industry people themselves. So I'm happy to be contradicted on some of these, but I would also like to know if my thinking is wrong, how I can clarify that. Okay. Lastly, I will ask Professor Chitra to share last two links. I would request you to first try the confirm link, because that's the way in which I'm planning to offer these to our students in the coming semester. So link 3 will take you to this page. Now, this looks a little bit ugly because down here, this is for C code, right? And I haven't yet been able to work out a way using this particular interface. This is code check. I haven't been able to work out how to get rid of this. You know, I have to sort of do some jugaad to make this happen. But here we are. We have to calculate the next even number. I'm sharing this example because this is C code. The nature of the ambiguity is slightly different. So for now, I will pause and take questions. And then I'm actually happy to ideate, reflect with you on this as well. And I want to hopefully, before the end of the webinar, do talk about the nature of one of the ambiguities in this question and how it is different to the corresponding to ambiguities we have seen so far for Python code. So with that, I will be happy to take questions. Thank you so much for your attention.
Thank you, Viraj. So there is one question from Ullas, which was asked long back. I think he had typed saying, I get the feeling that this is similar to revealing hidden test cases.
Okay. So Ullas, I think now that you've had a little bit more time to reflect, I don't know if you still feel the same way or you would like to ask a follow-up. I'll be happy to do so. So I'm somehow not able to see the Q&A. Okay, it's still the same one. Yeah. Okay.
Yeah,
excellent.
he says,
yeah.
I think I got better clarity. Okay.
Yeah.
Okay. One more question from Manu Madhavan. How to verify the correctness of GenAI responses in code generation and code explanation? And the second question is how to make sure that the code generated is in the student level, not use any higher concepts.
Okay.
Yeah.
So I think for the first question, I think since AI generated code can be incorrect, I do think it's very important for us to help our students develop the ability to doubt the AI generated code. First of all, I always tell my students that the last thing I want for you to is have a respectful relationship with your generative AI. You should always doubt what it is saying. And I do try and help my students develop this ability. So we have some prior work on what we call refute questions, which try and help students develop this ability. It's certainly true that this current technology that is used to for AI code generation can produce code that is incorrect and even code explanations that are incorrect, right? So, you know, unless you have a specification that you can trust or an implementation that you can trust, I have know of no other way to verify correctness, right? The second question I think is also very interesting, and thank you for raising it, right? I think what I have found is that the AI-generated code often contains syntax that students are unfamiliar with, right? But it is also many times true that that syntax is reflective of good programming style, right? I'll give you an example, right? So we may have taught our students how to populate a list using a simple for loop, but the AI might use a list comprehension in Python, right? So I think it's important for us as instructors to play around with these tools, understand that they can do this. And when they do produce code, if we are, for example, using generative AI in the classroom while during our lecture, I think we should be prepared for, occasional times when it produces code that is not using syntax that we have not yet covered. And then we should talk about that syntax. And we should talk about why that syntax is either better or worse than the syntax that we have seen. So, for example, list comprehensions sometimes have a performance benefit over traditional iteration. They're also cleaner to write sometimes. Of course, they can be more limited than general iteration. So we should talk about the pros and cons. Okay, so thank you for that question. Professor N.S. Kumar asks, once students...
He has asked, once the students get clarity on that question,
do
they write the code or again go back to the GenAI tool?
Okay. So firstly, Professor N.S. Kumar is the person who critiqued my teaching style and really put this excellent idea into my head. Why don't you do more live programming in class? And I always used to be terrified of live programming. I told him that, I'm so scared that I'm going to make silly mistakes and waste all my time trying to correct those mistakes in class. And his point, which was an excellent point, was, why are you so scared? I mean, that you're demonstrating to your students how you go about recovering from these errors. So you should do more live programming. And I'm so happy to tell you, I do lots of live programming. Now, it's just that I get my AI to do live programming in the class, and then we all together critique the AI-generated code, right? Now, to your question, what do the students do? I'm actually leaving it entirely up to them. Well, in the first semester where I started using this, which is the the fall of 2022 semester, when we told our students, Copilot exists, go ahead and use Copilot. A few months later, ChatGPT exists, go ahead and use ChatGPT. I surveyed our students and said, look, at the end of this semester, I said, are you using these tools? And they said no. And many of them said no. And I said, well, why aren't you using these tools? And they said, well, when they interview us for jobs, we will need to know how to write code manually. Right? I'm finding that now students are much more comfortable with using these tools. So I'm actually agnostic as to whether they do or don't use GenAI. There is an interesting question here. Is it easier for the student to recognize ambiguities if they're writing the code by hand or using a GenAI tool? Right? If they're using the GenAI tool, as I indicated during the talk, it could be that the fill-ins to the ambiguities that were made by the AI might be missed by the student. Whereas if they were writing the code themselves, they might have to think about these missing cases. They might more easily be able to think about these missing cases. I think this is a fascinating area of research, and I hope somebody here would be interested in examining this question. Yeah. So thanks for those questions.
Yeah, another question from Ullas. He's asking, an interesting angle or approach to tackle the issue would be to ask them to code really large code bases, like, say, for example, building a compiler. This kind of problem statement, if fed to GenAI, would not immediately give the full answer. Also, it helps students develop the ability to decompose large problems into manageable chunks.
Yeah.
He wants your opinion on.
Yeah. So I certainly think the ability of students to decompose large problems into manageable chunks is critical. We do get to that even in introductory programming. I think we should. Whether we can scale it out to problems as large as what you have suggested might be a bit challenging, but I do agree with the problem decomposition ability. Once again, this plays often to AI strengths. Again, I would encourage you to try this. Take a complex task, maybe not as complex as the one Ullas has suggested, but nevertheless one that does require multiple steps. And you may recall from when I explained the 6C paper that we had done, if you prompt your AI to say, step 1, do this, not only will it write code just for step 1, but then it will suggest a step 2 and a step 3 and write code for that as well, right? So thinking step by step is something that these things are actually quite capable of. And again, they can be quite eager, and potentially they can go off on a tangent, right? But yes, they can also be assistive to students, right?
There is a follow-up question from Professor N.S. Kumar. If there are alternative solutions for the same question, could the students be asked to compare them?
Okay, Professor N.S. Kumar, I think by alternative solutions, you mean functionally equivalent, but maybe, say different algorithms or, different problem decomposition or different code design. I think that's what you meant. And then could students be asked to compare them? Absolutely, right? Because there may be many ways of arriving at the same functionally equivalent solution, but some are, say, more efficient or better designed and so forth, right? So absolutely, there is opportunities for doing that as well. Yeah. And would they go back to GenAI tools? Once again, I don't know if they will or won't. As I said, from our perspective, we're saying if you'd like to, go ahead. Our belief is that our students should be allowed to use these tools, unless we have very good reasons for saying don't use these tools. And for such tasks, we feel that these tools could actually aid their thinking process. As we discussed a little bit earlier, there may be an argument that they sometimes are, could actually harm that. But I think that is a question that is definitely worth investigating, right?
And Jagannathan L has asked, this probing skills is a nice approach. I feel that our teaching should also be oriented towards this. I think that's what you are advocating for. So can you give your comments on that?
Yes. So certainly, I mean, through ACM India, we have been trying to conduct several faculty development programs where we do talk about this amongst other ideas. And yes, we certainly agree that it's worth discussing and worth sharing. This webinar too has given us a chance to share this idea. And if you think it's useful, please do try it, and please reach out to me if I can help in case you have, hit any kind of stumbling blocks. I'll be happy to help.
And Sashi Kumar is asking, which one of these platforms, that is ChatGPT or Copilot, or which one is generating better codes, or can you comment on that?
So I always encourage my students to use the tools that are integrated into the IDE rather than ChatGPT, right? Because those tools do provide this more interactive experience, right? Where you try an idea out, you see the code. If you're good at recognizing what the code is doing, then you can accept it or reject it, right? Now, I must say that I'm sure I know there are many experienced programmers on this call. And I think the perspective of many of us who have learned our programming prior to generative AI has been, why should I use these GenAI tools? I mean, if I know that they can make mistakes, then using the GenAI tool to produce code and then spending time critiquing or refuting that code, I might as well just write the code myself, right? And I think that's absolutely valid. I have no contradiction to that statement. But for our novice programmers, the students who we are teaching, I think it's a fair question to ask, right? I mean, if they learn this way and they still make it up to the top of the same mountain that we think we have scaled, it's just a different pathway up that same mountain. Who's to say that the approach we took is necessarily the best way up that mountaintop? I think that the proof has to be in what can they do with the skills they have learned. I mean, if there is evidence that by quote unquote relying or leaning heavily on generative AI tools, they are deficient in some sense that is practically important, then I think we should try and get evidence for that. So far, at least, I'm not sure. Right? Your follow-up question is around, are there such tools for aiding legal and medical domains? I'm really not so familiar with those, so I really can't answer those. But thank you for the question.
Yeah.
Okay, so while we wait for a few more questions. Let me just share this. I hope my screen is still visible, right?
Yes, it is visible.
So I'm going to actually jump over to the ask question, right? So this is the next even function. It's supposed to return the next even number for a given number n, right? And one of the things that I would like my student to think about now that this is C programming is what if n is so large that the next even number will overflow, right? What does the client want in that situation? This problem, of course, doesn't arise when we're talking about Python code because there is no a priori upper bound, for integers in Python. But this question does make sense, right? In Python, in C, right? So if I take this is the largest representable integer, assuming 32-bit ints, then what does the client want, right? And in this case, the client wants this because this just happens to be the largest positive even number that is representable. Now, this is just a very weird request, right? But did you even think about this, right? Or even this one, right? Because this one is the largest representable positive integer. And on this one as well, the client wants this. So it's not simply a matter of n plus 2 or n plus 1, depending on whether n is even or odd, right? It's thinking about these kinds of issues, right? Now, I just wanted to share this because this problem doesn't appear in C, in Python, but these kinds of issues around the limits of what we can and can't represent, of course, is very important, right? So I just wanted to share that, right? These problems do allow us to explore such avenues of ambiguity as well. Okay, so let's see. So yeah, Professor Anush Kumar is saying, yeah, I'm assuming size of int is 32 bytes. Yeah, so maybe I could write the expression using, say, size of, and it might be more, generic, right? So rather than picking 31 or a constant like that, maybe we do 8 times size of and some expression involving that, right? Okay, so Professor Chitra, if there are no more questions, I think we can
Yeah.
wrap up.
Yeah, there is something which was there with, I don't know, but what he's asking, Sashi Kumar, something was there. Is it similar doing calculations manually or by using calculators? This analogy applies to using.
Okay, I think where I know, yeah. So I think, we do have had this sort of kind of discussion of this question. Are we losing certain abilities by relying on GenAI tools, perhaps in the same way that we lost certain abilities by using calculators rather than doing, calculations in our head, right? And I think it's undeniable that certain mental capacities did get lost when we switched to using calculators. On the other hand, I think new opportunities opened. I mean, if we are not stuck with doing calculations, maybe we can use computation to study certain mathematical properties in a more intuitive manner and understand, or recognize certain patterns that indicate some underlying mathematical truths in a way that just wasn't possible before, right? Whether something like that also opens up for us here, I think is still too early to say. It's certainly the case that because these GenAI tools are not perfect, we can't use them with quite the same confidence as you can a calculator for the task that the calculator is good at, right? So I think things to explore here.
Yeah.
Yeah.
And thank you, Viraj. I think it was a great talk. I think, like you said, that now that Gen AI has become prominent, definitely we cannot stop students from making use of it. Definitely they are going to use it. So in that scenario, how well the educators can make sure that the right kind of skills are imparted to them and a different way of assessing so that they have acquired the essential skills to go to this real world and be a valuable professional with the right kind of productivity. And that's what you are talking about, I guess. So definitely that change in pedagogy and assessment, we need to reflect, I guess, and you have given a starting point for that. Thank you so much for that interesting talk, and thanks everyone for attending this webinar, and we will come back with another interesting webinar in a couple of months. Thank you so much. Yeah.
Thank you.
Thanks, Viraj.